Okay, so I just stumbled across this crazy thing. There's a Go microservice that sets up a completely in-memory FIFO message queue.
Wait, seriously? A whole message queue just living in RAM? That's wild. How does that even work?
Right? It's like if your RAM just took on a life of its own, keeping track of messages as they come in and out.
Exactly. And the fact that it's in RAM means it's super fast, right? But what about data persistence?
Good point. Since it's in RAM, it's definitely volatile. If it crashes, poof, all that data is gone.
That's kind of scary, actually. So you'd really want to only use it for non-critical messaging then?
Totally. It's perfect for scenarios where speed is key, like processing real-time notifications.
Oh, that makes sense. Like, think about a chat app. You don't need to save every message, just the latest.
Exactly, and the beauty is that it's a single binary. No heavy dependencies, you just run the binary and you're good.
That's so convenient. So deployment is a breeze. You can just whip it up anywhere.
Right? It's like having a lightweight tool in your back pocket ready to spin up at any moment.
I'm trying to picture this. All these message flows happening in real time, all in memory.
It's a bit mind-bending, isn't it? And think about scaling. It can handle a ton of messages depending on your RAM.
Oh, that's a game changer. If your server has more RAM, you just handle more messages, like adding lanes to a highway.
Exactly. And the simplicity of just running a binary means less overhead, keeps your architecture clean.
That makes me wonder, could this sort of architecture influence other types of systems, like databases?
Ooh, great question. I think it could pave the way for faster in-memory databases that prioritize speed over permanence.
Yeah! Imagine a database that temporarily stores data for high-speed operations and then clears it out.
That's such an interesting idea. It's like having a super-fast workspace that you clean up after every task.
Exactly. And I'm thinking about potential uses in analytics, too. Fast calculations without keeping old data.
Totally. It could change how we think about temporary data. Just keep what you need, discard the rest.
I love that, and it raises the question, what if we don't actually need long-term storage for everything?
Right? It's about optimizing what's necessary, could save resources, and speed up processes.
And that might lead to entirely new workflows. Could we then rethink how systems are architected?
Absolutely. It's a paradigm shift. So if RAM is treated more like a playground, it changes everything.
I never thought about it this way, like embracing temporary solutions for better efficiency.
Exactly. It's liberating in a way, focusing on immediate needs rather than permanent storage.
So, going back to the original microservice, what's the name of this innovation?
It's called ZAP. Such a snappy name for such a fluid concept.
zapq, I love it. It's memorable and hints at that quick functionality.
Right? It's catchy. Plus, it embodies the energy of instant messaging and speed.
And it makes me think, are we heading towards a future where we embrace memory in a whole new way?
Definitely. The implications can redefine speed in tech. It's an exciting frontier.
And it leaves you wondering, where else can we streamline processes by leveraging RAM in this way?
Exactly. So many avenues to explore. I feel like we're just scratching the surface here.
Totally. It's like this idea is just the beginning, leading to a new wave of innovation.
And isn't that the thrill of tech? Constantly evolving and surprising us.
Yes! So let's keep our eyes peeled, because who knows what's next in this rapid evolution.
Absolutely. I'm excited to see how this in-memory approach spreads across other applications.
And maybe we'll even start to rethink the whole concept of data permanence. Crazy, right?
Mind-blowing. It's shaping up to be a really fascinating journey for technology ahead.
Definitely. All this talk makes me want to dive deeper into how other technologies can adapt.
Same here. Let's keep this conversation going and see where our curiosity takes us.